Hi everyone, this video is gonna to discuss on one-sided limit, and follow from one-sided limit we can determine the existence of a limit. Let's look at the example, this graph. Consider this graph y equals to fx. We are going to find the limit of fx when x approaches to 0 negative, and we should know what it means by 0 negative. 0 negative meaning that when x approaches to 0 from the left hand side. Or you might think that 0 negative is a value which is a little bit less than 0. Alright, so when you have when x approaches to 0 negative, we focus on the 0. This is the value of 0. Then now we are going to find the limit when this when this x approaches to 0 from the left hand side. So we will trace the graph, only focus on the graph on the left hand side of the 0. And we have the graph, left hand side of the 0, we have the graph of this. So we trace the graph. As the x approaches to 0 from the left hand side, the y we can see that it is approaches to negative 4. So you can see that this is negative 4. The answer for this limit of fx when x approaches to 0 negative is equals to negative 4. So we first of all, we must know that the 0 is not means by only this point, but the 0 is this the entire line of the y-axis. This is the x equals to 0. So for this question, we must think of when x approaches to 0 negative means that when the graph is approaching to this line. Approaching to this line is x equals to 0 from the left hand side. Then the y approaches to negative 4. This is the meaning. Alright. Then now we proceed to the next question, B. Limit for fx when the x approaches to 0 from the right hand side. So if you have this question, you must focus on the right hand side of the 0. Because 0 positive meaning that x approaches to 0 from the right. So we focus on the right hand side of the 0. Then we know that the x equals to 0 is the entire line of this red line. So we must see that our graph, when the graph is approaches to reaching this red line, where is the y approaches to? So now obviously the y is approaches to negative 4 as well. So we can say that since the limit, the left hand limit, I call this as a left hand limit, is equal to the right hand limit. Right hand limit meaning that when x approaches to 0 from the right, both of them equals to negative 4. Then we can say that the limit when x approaches to 0, this is called two-sided limit, is equals to negative 4. And of course, it is exists. Alright, so it is the existence of this limit is exists, and the value of the answer is negative 4. Now we proceed to the next example. In this question, I have again a graph y equals to fx. Firstly, we need to find the limit of fx when x approaches to 3 from the left hand side. So we know that find the line of x equals to 3. So x equals to 3, I will highlight with the red color. This is x equals to 3. This is the line that having the equation x equals to 3. So you are now going to find when x approaches to 3 negative, meaning that when the x is approaches to reaching this line, when the x is reaching this line from the left hand side, what is the y approaches to? Alright, so now we can see that the graph appear over here. We just trace the graph from the left hand side. When this graph is reaching the x equals to 3 from the left hand side, the y is approaches to 3. So the answer is equals to 3. For the other side, when the x is approaches to 3 from the right hand side, alright, meaning that when the x is going closer to the x equals to 3 from the right hand side, what is the y approaches to? So we trace from the graph, focus on the graph of the right hand side, then we just proceed to trace the graph from the right hand side. When this graph is approaching to this red line, then the y is also approaching to negative 2, meaning that this having the value of negative 2. So since these two having the different answer, we can say that our reason is limit when x approaches to the 3 negative, is not equals to the limit when x approaches to 3, right, positive, meaning that from the right side. And we can say that the conclusion is the limit when x approaches to 3, that is our two-sided limit, does not exist. Alright, so this is our reason given, and this is our conclusion. Here I have another example. Determine the limit when x approaches to a positive, x approaches to a negative, and the two-sided limit, finally, we need to find for any given a, meaning that later on the a will be substituted as either 1 or 2. For the question A, we need to substitute a as 1. For question B, we need to put it a as a 2. So now we focus on the question A first. First of all, we have this function a. Now we need to find the limit when x approaches to 1, because the a now I will substitute it as, I will replace it by the 1. You need to find this. X approaches to 1 from the right side. Now how to find this limit? I will need to substitute the corresponding function of fx, because the fx consists of two subfunctions for different interval. For the interval which is x not equals to 1, we have the subfunction 2x minus 1. And for the interval x equals to 1, we have the fx equals to 0. So now when the x approaches to 1 positive, you can just take one example to represent 1 positive. For example, 1.001. Because you think that the 1 positive is a little bit greater than 1. So I'll take one value to represent the 1 positive. Let's take 1.0001 maybe. So ask yourself, 1.001 is for at the first interval or second interval? Because for the second interval, it's just for the x equals to 1. And for other than x equals to 1, other value of x except x equals to 1 will take the first interval. Alright, so 1.001 will fall in the first interval. So we take the function of fx, we will substitute this fx as a 2x minus 1. Alright, so firstly, we will consider this x. See this x, whether it's for in the which interval, then we will take the corresponding function to put in as our fx, and then we use the substitution method. Substitute 1 inside, you will have a 2 multiplied by 1 minus 1. Finally, you get 1. And next, we need to find the left-hand limit, which my x is approaches to 1 from the left side. So now I need to decide that which function, either is 2x minus 1 or 0, will put in as my fx. 1 negative. What does it mean by 1 negative? You can think that 1 negative is 0.999. Then ask yourself, 0.999 is for in the first quadrant or second quadrant. If let's say it's the first quadrant, then you need to take 2x minus 1. If a second quadrant, then it will be equals to 0. So now 0.999 is of course not definitely is not at the second interval. It is in the first interval. So we will take the fx. We'll replace the fx as a 2x minus 1, and then after that you can use substitution method. Substitute 1 inside. You still will have a 1. So since we have the right hand limit equals to the left hand limit, then what can we say is limit when x approaches to 1 fx, that will be equals to 1, because these two taking the same value, then you say that this is equals to 1. Move to question B. The same thing, we need to get the right hand limit when x approaches to 2 from the right, left hand limit when x approaches to 2 from the left. Finally, we will find the x approaches to 2. So firstly, we need to determine what is the suitable fx to put in to, either it's 3x squared minus 6 or 8 minus x. So just consider that 2 positive is for in the first interval or second interval. 2 positive, you can take it, represent it as a 2.001 maybe. So 2.001 is 4 in the second interval. So we will take the 8 minus x to represent our fx. So now after you have decided which function to put in, then you use substitution method, put in your x as a 2, you have a 6. So easy, right? Then after that, proceed to the left-hand limit. As approaches to 2 negative, you can take a 2 negative as a 1.999. So this consider 1.999 either is 4 in the first or second quadrant. Yes, it is in the first quadrant because it is 1.999 is less than 2. So you put in the corresponding function, which is your 3x squared minus 6. Then you substitute the 2 inside. You have 4 multiplied by 3, 12, 12 minus 6, that will be 12. Then what is our conclusion now? Since we say that since x approaches to 2 from the right is equals to the limit when x approaches to 2 from the left. Our conclusion is, therefore, limit when x approaches to 2 will be equals to 6. And of course, it is exists. For this example, again, we have a piecewise function. Find the limit at x equals to 2. So when you are asking the limit at x equals to 2, 2 is the boundary value in our piecewise function. So we must use the one-sided limit to determine the limit at x equals to 2. So again, repeat the same procedure. We need to get the limit from right side and left-hand limit. Then only we can decide x approaches to 2 whether it is exists or does not exist. Alright, so to find the limit when x approaches to 2 from the right, we need to know which function to be put in as our fx over here. So ask yourself 2 positive, maybe you can take one value to represent 2 positive. That maybe will be 2.001. So 2.001 is 4 in the second interval. So you take the corresponding function, put in as a x over 2 plus 2. Then next, you will substitute the value of 2 inside. You will have a 2 over 2 plus 2. That will be 3. And for the left-hand limit, I'm going to take the first function because 2 negative is 4 in the first quadrant. First interval. Then you put in the function as a 5 minus x. After that, put in the 2, substitute in the 2. You have a 5 minus 2, you got 3. So since, what is the reason? If you have this value, the same value, you can say that this is equal to 3. This is your conclusion. But if the question asking for the reason, you must tell, since x approaches to 2 from the right is equals to the limit when x approaches to 2 from the left, then only you can make this conclusion that your two-sided limit when x approaches to 2 is equals to 3. Let's consider this question 7. Fx is given as this piecewise function. We need to find the limit at x equals to 2. Before we proceed to finding the limit, we need to simplify this function first. You can see that the x squared minus 4 can be factorized into x plus 2 multiplied by x minus 2 over x minus 2. And this function is valid for the x not equals to 2 for this interval. For the x equals to 2, the function fx will take the 3. It's a constant function when x equals to 2. Alright, then from here we can see that this function actually can be x minus 2 can be cancelled off. We simplify. Then finally our fx become like this. X plus 2 when the x is not equal to 2. And fx equals to 3 when x equals to 2. So now we want to find the limit when x approaches to 2, and very obviously the 2 is the boundary point where our graph will break at the 2. Alright, so you need to, for this kind of limit, you need to consider is a one-sided limit. Then only you can say that the two-sided limit exists or not. Alright, so get the fx, which x approaches to 2 positive means that you can say that the 2 positive is 4 in this first interval. So we are going to take this function x plus 2 to substitute replace the fx. Alright, Then you use substitution method. You have your 2 plus 2 equals to 4. The same method you would apply when x approaches to 2 negative, meaning that the 2 negative, example 1.999 is 4 in the first interval. So we're going to take this function x plus 2 inside and substitute the 2 inside the x. You have a 2 plus 2. Again, you have 4. Then the conclusion, before we come to the conclusion, we state our reason why we say so. We say that because the right-hand limit is equals to the left-hand limit, and they are both equals to 4, then our conclusion is limit when x approaches to 2 for f of x is equals to 4. Alright, so for the next video, I'm going to discuss on the limits, but it's a series of questions about the limits. There's a reinforcement practice. Thank you.